Okay, we're doing the 2015 AP Computer Science test. We're doing 1C, question 1C now. It says a two-dimensional array is diverse if no two of its rows have entries that sum to the same value. That is, so no two rows have entries that sum to the same value. So if any two rows sum up to the same value, we know it's not diverse. So here's a couple of examples. Here's the first example here. We have this row adds up to 16, this row to 32, 80, 28, 20. So this matrix is diverse because all these numbers are different. And then it tells you that in this case, matrix 2, this row adds up to 14, this one 35, 36, and last one 14. Because we have 14 and 14, this one is not diverse. So what we need to do is write a static method is diverse that determines whether or not a given two-dimensional array is diverse. The method has one parameter, a two-dimensional array 2D of int values. The method returns true if all the row sums in the given array are unique, right? So there's no duplicates. Otherwise, it returns false. So it's diverse if they're all unique. It's false if there's any duplicates. Yeah, the rest of that. And so again, once again, they'll tell you right down here, you must use row sums appropriately to receive full credit. So you have to use the row sums that we did before in the previous question, 1B. So how are we going to do that? Well, obviously we're going to use row sums. So it seems pretty simple, right? Row sums, we start out with the matrix. They give us that matrix, but we already have the row sums method, so we can generate this, right? We can generate this array. So we're going to do that, obviously. And once we have this array, now all we have to do is check, are there any duplicates? So how do we check if there are duplicates in an array? So like in this case, as a human, I can just look at it and like, 14 is there twice. But imagine, if you will, if there's more than 4 numbers, there's instead, a million. How would you do it? You can't just look at it. It's not going to pop out of you. So you're going to have to do it systematically. Basically, what you probably do is, you take the first number, 16, say, okay, 16 I'm going to do, and then you go through and check the rest of the list to see if 16 is there. If it's not, then you're like, okay, 16 was not there, we're good. You do 32, and then you check the rest of the list, see if 32 is there. And you keep doing that until, maybe you find, if you ever find the same number twice, then you're done, right? Because if I was checking for 16 and I found 16, like say that down here, I know, oh, that's a duplicate, I'm done, because it's not unique. If though I keep doing it and do it and do it all the way to the end and I don't find anything, then I know there's no duplicates at all. So I'm done again. There's no duplicates. So it is diverse. So in this case, I look at the 14, I pick 14, I go, is that 14? Yes. No. Is that 14? No. Is that 14? Yes. Oh, okay. So false. This is not diverse because I still have 14 in this one. So let's implement that. I'm going to do here. And the method they want us to implement is public static boolean is diverse. Static boolean is diverse and takes in a two-dimensional array 2D. All right. To capital D. I actually didn't check that. Capital D. So what I have to do first thing is, like I said, they're giving me this whole array. I just want this. They're giving me the two-dimensional matrix. I want the one-dimensional one. So I'm gonna call that, the sums array, and let's make it prettier. And that is, I'm gonna call row sums of array 2D. So there, I properly called the previous one. I have my sums array. So now I need to do this business of checking the first one, grabbing the first one and checking against the rest. So we're gonna need nested loops for that. So how does that work? So I is going to go from 0 to sums.length, and then j is going to go all the way to sums.length, but this guy is not going to start at 0. He's going to start at I plus 1, right? Because you'll remember we started out, let me erase that. And we started out, say this is our array here. We have the first number here. We want to check it against all the ones after, right? So we grab the first number. This is going to be I initially, and j is going to be here. So I is going to be 0, j is going to be 1, 2, 3, 4, right? And then next time around, I is going to be 1. So I goes away. Now I is 1, and j is going to start here. Oops, that's an I. J, weird j, but j is going to start here. So I is going to be 1, j is going to be 2, 3, 4. Right? So that's what we're doing here. Okay. And then we're going to check if sums of I equals sums j. So if the element of I equals the element of j, then we have to return false, right? So that means we found a duplicate, right? We found a duplicate. And so we're done. At that point, we're done, because now we just need to find one duplicate, and we know it's not diverse. If, however, we do all this to the end and we never return false, that means we are down here, then we can return true because there are no duplicates. We have just proven, by exhaustive testing, by comparing every one of them to every other one of them, we have proven that there are no duplicates, and so we feel safe in returning true. It is diverse. There are no duplicates in the sums. So let's test that. Make sure it works. And is diverse. So we want to do is diverse of M1. That should return true. And is diverse of M2 should return false when I run it. Let's see. True, false. Okay. And that's what. So these are the same matrices in the example. So 1, 3, 2, 7, and 1, 1. These are these matrices right here. So true and false. So that works, and you'll notice that unlike these other ones where we were able to use the for each, in this example we're not able to use it. For this particular case, just because of the way it's set up, we totally need the indices, and we need to index from I0 to the end, and then from j, which is I plus 1, to the end. Now another thing, one last thing people might be worried about is, okay, what's going to happen when I gets to the end? So let's say the length is 10, so the last index is 9. So when I is 9, then we come here and j is going to be 9 plus 1, or 10. Well, clearly that is 10 is less than the length, right? 10 is less than 10. It's not less than 10. So this is going to fail, right? So we're never going to enter the inner loop. Because if the length is 10 and j is 10, we never enter the loop. You gotta remember that. So that's it.